Hello again, John here for another video in the series for the SD2IEC. In the other videos I showed you in the overview how that interacting with the SD card without using the file browser is a bit clunky because you have to do open 15,8,15. Now in my case at the moment it's (9), 15, if you wanted to mount an image you have to do cd:/image.d64 and then close 15. But while in that video I loaded a piece of software that I'd wrote in my youth called the expansion commands, extended basic commands for the 64, and in that software I'd written some basic disk operation commands like catalog, which shows the directory of the drive, rename, copy a file, save and verify a file at the same time. So what I did is I have taken that program that I wrote and made it better because I'm older and I know better, and I've also added the commands in for the SD2IEC. So I'll just show you, and it's there. It's called TD-SOS. I've called it that at the moment. It might change depending. It's an alpha test. So if I load it in now, so I'll load it in using SJ loader. Now I've figured out how to make it work. Right, and then I do a run, stop and restore, which will activate it. There you go. Now, at the moment, by default, the current device is 8, which is my disk drive, and as you can see, it's come up with a read error because I haven't got a disk in there. So I'll change it to device 9, right, and do status on it. There we go. Don't worry about the syntax error. For some reason it doesn't like the SD card doesn't like the initialization command, so I've got to figure out how to test to see if it's an SD card. But if I restart the SD card just temporarily, I can show you that it is here. So I'm waiting for the light to go out. There we go. Now if I do status, there you go. Okay. Right. The commands that I've put in, if you type in help, you'll come up with these set of commands. Now, this is only a first cut. This is what I've been able to do quickly. So we've got a catalog. Now, catalog allows you to see the directory that you're currently in. So if I do C-Shift-A, which is the shortcut version of catalog, you could actually type in the word catalog. There you go. You're actually seeing the directory that you're in. All right. Next one is initialize, which just reinitializes the SD card, the disk that you're in. So it's either the SolidState disk or floppy disk, and it just initializes it back. Status, well, that just tells you if it's okay or not, or tells you what the last error was. Collect. This. Now it won't do it for the SD card because it doesn't understand the command, but what this does is on the floppy disk, if your disk is a bit of a mess, it will reorganize the disk for you and make it run quicker. It's like a defrag for Windows, but it was for the Commodore 64. So what I'm going to do at the moment, so I'm just going to do catalog. There you go. And what I will do here is if we go into there, so we've got, next is rename and then copy. So what I'll do is I'll do a copy first, because I'm going to copy a file so we can tinker with it. So I'm going to copy TD-SOS, and I want to make it into, I want to make a copy of it called JCD-SOS. Yes, please. So it does it, it says it's okay. If we do catalog, we should have a new file called JCD-SOS. There it is. Alright? But, oh no, didn't want to call it JCD-SOS, so we'll rename it. So rename, or R-Shift-D for short, and it's JCD-SOS to C64DOS. So yes, we do. So if I do catalog, it should rename it now to C64DOS. So that's copy and rename. Scratch is delete. Scratch is delete. So if I want to delete it, so scratch C64DOS. Am I sure? Yeah. It says it's scratched. Have a catalogue and it's gone. Header is format. So I'm not going to format it, but I will do a format once I've loaded an image. Basically it's header, disk name, comma, identify, and you can give it a number as the identifier, 2-digit code, and then that will format the image, or it will actually format the floppy. Chain, well, chain is sort of pinched from BBC Basic. BBC Basic allowed you to save a program and load a program and run it. Well, in this case it's saving a program and verifying it directly after. So if I create a small program, print John, oops, forgot that, 10, print John 20, go to, whoa. Go to 10. So if I list that, so there's the program, run it, hey presto, it works. Might change it a little bit, make it a bit more obvious that it's running. Put a semicolon there. So run, there we go, that's better. So here's the program. So if we do chain, again, chain JCD test, because it already knows we're on device 9, it will save it to device 9, then verify it, and as you can see it's done it. So if I do new, so if I do list, it's gone. Load JCD test, comment 9. There you go. So that's chain. Then we've got kill. Now kill stops this system in its tracks. So if I type in kill, that's it. The DOS operating system no longer is available. And and I can do that, and I can show it you if you want. But I'll show you at the end. Help is exactly what it is. Device I've shown you, that allows you to switch from which device number to another number. Mount I'll show you, root directory I'll show you, but what I'm going to do now is go to catalog and we'll start navigating the directory. So to change the directory it's called switch dir or S-Shift-W, and you type in the directory name, so my disks, yes I'm sure, do a catalog, there you go, these are my disks, and as you can see I've got other directories, so I'll do switch to my games. Are you sure? Yes. Do a catalogue, and there are some games that I've been backing up my disk archive. So now I've navigated down to another directory. But what happens if I want to get back to the root? Well, it's dead easy. I put in the command, so it's a root dir or R-Shift-O. It asks me if I'm sure, yes, and if I do a catalogue, it sends me back to the root directory. So I'll switch again to my disks, yes, and then catalogue, and then I'm going to mount one of my disks. So here we go. So we will mount PETAS, yeah. So we'll mount, or M-Shift-O, if you want, PET-AS.D64. Now these are assignments you did when I was taking my A level at school, and we had to do everything on a PET until the BBC came along. So yes. So now if I do a catalogue, there you go. I have mounted that image, and now I can see what's in that image. And as you can see, I did quite a lot of it's in machine code. There's Dale monitor. There's my 64 monitor statements, number 25. I did Cecil assembler, I wrote a word processor. Crikey. I'll have to see what some of all these things are. Anything with STS is machine code. So STS dump, STS label, STS old. Oh, an old command. I remember that. But say if I've finished with this, then if you go help, you'll see there's a command called dismount, or D-Shift-I. If I do dismount, it puts me back into the directory where the images were. Then the other one is erase directory. Well, we can make a directory. So I'll go back to the root first. Root dir catalog. There we go. So we can make a dir, or M-Shift-A if you want, and we'll call this JCD-DR test. Oops. Try again. Yes. There we go. And if we do a catalogue, we should see there's a new directory there. Yeah, JCD-DR test. We can also erase that directory. So if we wanted to erase it, erase dir or E-Shift-R, and it's JCD-DR test. Am I sure? Yes. And it tells me I've scratched one. So if I do a catalogue, and it's gone. What else have we got? Root dir device, and about is just basically me blowing my trumpet. TDSOS Computers proudly presents TD-SOS, the disk and solid-state operating system for the Commodore 64. If you have any suggestions or features, please email me. This program is distributed in the hope it will take the complexity of talking to a floppy disk and a SD2IEC SD card easier, and you will find it useful. The program is provided with no warranty of any kind. Use this program at your own risk. Enter help for future instructions. So, that is the TD-SOS system that I've written. And what I'm going to do now is we'll switch to the computer, and I'll show you some of the code. I'll see you in a minute. Bye. Hello. So we're back on the computer, and we're looking at the source code for TD-SOS, or as I called it in here, TDSOS. And this is basically the machine language that runs all those commands. And so what I've done is I've written this program that it pretends it's actually a cartridge, and it resides in memory location 8000, because that's where most hardware cartridges load into when you plug them into the back of the 64. So I've done some code that interacts like it's a cartridge. So it takes over the MNI interrupt and the reset interrupt vectors, and so I've had to write the interrupt vectors here because of the fact that I'm pretending I'm a cartridge. So what it does, it sets up the I/O ports, does the RAM test, initializes the VIC chip and the screen editor, copies the basic vectors to RAM, initializes basic, prints the basic startup screen, then loads the stack pointer value, and then it puts up my text that says that it shows you that my routine is actually enabled. then it initializes my routine and then jumps back to the 64's NMI interrupt exit. So I've had to make sure that handle the MNI and all the subsequent things for it, because with me taking over I have had to, you have to do it yourself. So what happens is the NMI interrupt fires when you do a run, stop and restore. So I've had to make sure that I do everything that the 64 does to reset the 64 back into a working state, which is what I do. And then I put the screen up, which is the disk and SolidState operating system version 1.0 alpha, and then we continue. So this is the start, and what the start does is it overwrites some of the basic vectors. So it overwrites the tokenizer and the error vectors. And what happens is the tokenizer when you type in a command in direct mode and then press enter, the 64 then goes to the tokenizer vector and does an indirect jump. And I've spoken about these addressing modes in a previous video. Does an indirect jump on 304 and 305, and then the basic ROM, it points to the basic ROM, and then the basic ROM tokenizes that line into basic, and it then executes it. Well, what I've done is I've overwritten those vectors to make it come to my tokenizer, which then tokenizes for my commands first, and then sends it off to the basic ROM for tokenizing the basic commands. And then what I've done is I've opened a command channel. I've initialized the DOS buffer. There's the command channel. So I've got and then protected the machine code by altering the basic pointers to point at the last available byte in basic. And what happens is when you do free open zero, I think it's free open bracket zero close bracket, gives you the number of bytes available. Well, when I do this, it will reduce those bytes because I've protected it. Then we've got the how to open a channel. So basically I temporarily store all the registers onto the stack, so because I know I'm going to be changing them and I don't want to destroy them. I then open a channel for the device using the command type, and then I set the output device and I tell it what I want to execute, which is in this case initialize, send it to the channel, open the device, and then I restore the registries from the stack back. I've also got a closed command channel, which basically clears the channel of any instructions. I load the disk command channel number, and then I close the channel. So here's the tokenizer, and what it does, it checks for if I'm in direct mode or not, and if I'm not in direct mode. So here, when it does this, it checks to see if it's found a tokenizer instruction. But what I do is I load the program status mode. Is it greater? Is it less than 128? Yes, it is. That means I'm not in direct mode. I'm in run mode. Jump away and go to the 64's tokenizer, because my commands only run in direct mode. If it's direct mode, then we reset the tokenizer. We get the next character. Did I find an instruction? Yes, I did. Then it goes off to found an instruction. If it didn't, then it goes back to the basic interpreter and does that. So if it finds an instruction, it runs through the instruction, comparing it with my command list. If it finds, if it runs through and carries on running through and finds a character with the high bit set, then we found one of my commands, and it goes to TK8. down here. There we go. And because it's found the command, it then loads the low bit, high bit and low bit onto the stack, and then goes back to the character get. Because what happens is then, because you jump to the character get, which gets the next character, when it does its return from subroutine, it's actually going to return to my command that I've set here, because I've just put that onto the stack, and then it runs the stack, runs my command. So I've got a couple of other things. So ready, which is just prompting ready on the screen, return to the 64 tokenizer, show syntax error, and here we go. So the first command is catalog. So basically we set up the channel to load the catalog. We get, because it loads as a program, the first two items are going to be the low byte and high byte link line. And if the high byte is 0, we know that it's reached the end of the program, because at the end of the program there's 3 zeros which indicate end of program. So if it's equal to 0, then it goes to the end. If it's not, it goes and gets the low byte number, I store it, get the high byte number, and then load the low byte, and then I go to the print decimal routine, which takes the low byte and high byte, so the X is low, accumulator is high, and then prints a decimal number. Then I print a space, and now I'm getting into getting the basic line. So I get the character from the basic. Is it 0, which means end of line? Yes it is. Then go to end basic. No it isn't. Print that line, do a key test to see if I've pressed a key, and if I have, pause, jump to the next line. The end of line, it's basically I load a carriage return and print it, and then go back to get the next basic line, which is here. And that goes round and round and round until it hits the end of the basic line, and then does the end, which is basically print a carriage return, clears my channel, closes it, and then jumps to the ready. And then the key test routine is, so I'm just kept testing it, and then I'm delaying a bit, and then I'm retesting to see if the key's been pressed again to restart it. So here we go. So this is the general DOS routine. So I set up the disk command channel, I put a carriage return at the end of the DOS buffer, I ask are you sure, I initiate the channel, send the DOS command to the channel, clear it, and then clear the buffer, because I don't want the remains of the buffer to interfere with the next one. And then it jumps to the status channel already open, which is here, and then displays as the status of what happened to that instruction. So let's say if you did a rename and the file doesn't exist, it will come back with file not found, or stuff like that. Alright. There's the are you sure prompt, so I'm testing there. So this is the initialize, so I'm sending the command and collect, and that's basically all it does. I can't go through it all bit by bit, but this will get bigger and bigger and bigger as time goes on. As you can see, some of it bits I've still not commented yet because I ain't got there. But then we come down to here, which is where the end of the old system stopped, and I start with all the SD commands. So here we go. So get number from the command line. So that's me to get a number from the command line. So here's the first one, which is device, and then we've got mount, and then dismount, root directory routine, change directory, which is switch directory, make a directory, remove directory, about, which is the about function at that point, and there's some other commands as well on the SD2IEC that I have not incorporated into this yet because I'm just testing it out, and I want to actually get this out there for people to mess around with and give me feedback. So with that, I will call it a day for the at the moment. I will put a link in the description to get this program, and see what you guys think, and hopefully I'll get some positive feedback. Negative feedback's good, because you know, to critique someone's work is very important. So you know, I'm always up for the negative feedback. If I've done something wrong, I have to know. You've got to tell me. I'm a programmer. You've got to tell me that it's wrong. And so I'm hoping that there'll be more positive feedback than negative feedback, but all feedback is welcome. And I will see you on the next video.